Is this thing working? Okay, the video's not frozen. It's recording. It's gonna be awesome, and it's gonna work this time because I've already gone through everything. And I'm mad that I'm re-recording this. Okay. Being angry at you, Swivl. Okay, we're gonna go over histograms, frequency polygons, and what we call ogives. Histograms are pretty commonly used. You've done those probably since middle school. Frequency polygons is what we call a line graph, is another word for it. Cumulative frequency graphs are ogives, and then also that'll talk about cumulative relative frequency. Okay, we're gonna make each one of those from the data. So we have this data over here, and it keeps skipping too. So, okay, it's gone, it's still working. Okay, histogram is a graph that displays the data by using contiguous vertical bars of various heights to represent the frequency of the classes. Contiguous means that they touch. Okay, they're continuous almost. Okay, our class boundaries. So this is actually a question about record high temperatures and how many days of those record high temperatures have occurred. So with this data, we're gonna make our frequency. We need to go up to 18. So we've already done that. We know we need to go up to basically 20, and it's easier if we count up by tens. Make sure you're counting up every time by the same amount. So we need to go up to 20, so there we go. Class boundaries for a histogram, we need to set the lower and the upper boundary. 104.5, 109.5, 114.5, 119.5, 124.5, 129.5, 134.5. Okay, with that we also need to say these are my record high temperatures, and then we need to say the number of days that have happened. So our histogram that we're making, we go up for the first thing to come down. Up 8 for the next one. Make that next bars all the way down. And then we're gonna go up to 18. That was the highest one, so that should have to, the rest of them are not gonna go up that high. 13 for the next one. 7 for the 119. And 1 for both of the last two. Okay, that's what your histogram should look like. Next, we are going to make a frequency polygon, more commonly thought of for the last couple years as just a line graph. Okay, line graphs, these frequency polygons, are going to use the midpoints, or the most important piece there, midpoints of the classes. So we have to go through and figure out the midpoints. When we add 199.5 to 104.5, we get 204 divided by 2 is 102. When we do the next one, we get 107, 112, 117, 122, 127, 132. Okay, we're still doing those things with those same frequencies, except for these different pieces are the pieces going on our bottom axis of our graph. We should still put temperature and number of days. I'm gonna be lazy. So I have 102, 107, and I don't have room right here, but you guys should all have room on your papers. 117, 122, 127, 132. Now I'm counting up. I'm going to use the same scale I had before. 5, 10, 15, 20. Make sure to label these things. 102 was 2.
What did we do yesterday? What numbers? 2 and 3?
3 through 8. 8.
107 had 8 of those things. 112 had 18 of those thingies. 117 has 13.
Oh, I like this one.
122 had 7. 132, and those ones both had 1. Okay, frequency polygon, we start at 0. Go up to our first dot, connect all the dots from left to right. And go back to 0. Okay, all the name of frequency polygon is that this thingy just made a polygon if I kind of connected those ones. This would be a big polygon. We don't have to color it or anything, but that's why it's called a frequency polygon. Line graphs also. This book is not going to use line graph, so be good with that. Okay, next one is an ogive. Ogives are that we're doing the cumulative frequencies. Cumulative means we're adding them up for the classes. Okay, so we need to go through. We're also going to make some different classes. We're going to say less than the lowest number, less than 99.5. Our next class will then be less than 104.5, less than 109.5. So in order to do that, how we're doing that is we're adding these up. So how many of these things had days less than 99.5? From the data that we're looking at, our cumulative frequency is 0. We didn't have any days that we had record of that were under 99.5 for our high. Okay, less than 104.5, we had 2 of those. What about less than 109.5? Well, we had 8 plus 2, so we had 10 of those. Less than 114.5, we'd have lots of ditto marks. Okay, 114.5 would then be 10 plus 18. So I get 28. So basically we're just adding up all of what our frequencies are. 128 plus 13 is 41, plus 7 is 48, plus 1 is 49, plus another one is 50. So that means we need to actually make a new scale for this graph, and I need to go up to 50. My little thing that I made up didn't go up to 50, so if I counted by 5, so I'm going to count by 10s. 10, 20, 30, 40, 50. Okay, those numbers that we're going to use is less than 99.5, 104.5, 109.5, 114.5, 119.5, 124.5, 129.5, 134.5. I should be writing the 0.5s, just don't have much room. 99, I had 0 days less than that. 104.5, I had 2, and then I had 10, and then I had 28, and I had 41. Then I had 48, then I had 49, and then I had 50. Okay, so what you're going to see here is we're going to always connect the dots then. Okay, what you'll also see sometimes is cumulative relative frequency. Cumulative relative meaning in percentage or like in relationship to the whole. If I was doing that, I would figure out my percentages on this side. Those percentages are the only thing that would change then. So I would still have 50%, or 50 was 100%. Down here is 100% or 0%. Okay? Then I would still have, instead of 40, I would have had 80%. So the only thing that changed is that right-hand scale. Even the dots shouldn't change when you're doing that. 60%, 40%. Okay, we also have to talk about the shapes of different graphs. Let me see here, that's going to change my slide. Okay, your procedure table is listed right there for that slide. It is also in your book. Then we have different types of distribution shapes. So the one thing that we will do a lot of, especially when we get to chapter 6, when we go over what we call normal distributions, are the bell shape, or also called unimodal. Okay, when you're asked to describe your distribution, you're basically using one of these types of wording things for it. Uniform, all the same, straight across after you get your chart. So if you had also, if you were doing a frequency polygon instead, it would just be your dots instead of the bars. Okay, you're still doing the same thing. You still have that same look. Dot, 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 dot. Sorry, I'm kind of running out. Okay? J-shaped. It goes up, and there's nothing less than that. So it's just, I don't know exactly why it's called J, but it's a flat side. Reverse J-shaped is the side is flat. Right skewed and left skewed are what we see more in like real actual data, is that it kind of has a little bit of hump, but then it has a big long tail that goes off to the right side. So that's a right tail. And on the left side, it has a tail on the left. Okay, bimodal, 2 humps. This one up here only had 1 hump, that one has 2 humps. U-shaped is there's data on both ends, but not much in the middle.